Hi, I'm Anusha. We, a team of 4 members, have done a project on enhanced independent component analysis and its application to content-based face image retrieval in 2D, 3D and multimodal. My project mates are Priyanka, Navyasri and Rajita. And we have done this project under the guidance of Professor Y. Vijayalatha ma'am. In our real time, we may have many biometrics for unique identification of a person like iris and fingerprint, where the presence of person is must. Whereas in face recognition, the presence of person is not needed. Here, in this project, we explored study carried out in the field of automated face recognition, identifying the problems encountered and the most promising methods of overcoming these difficulties. Taking this knowledge base as a starting point, we strive to improve the current state of the art with the ultimate aim of producing a highly effective face recognition algorithm for use in such application areas as secure site access, suspect identification, and surveillance. Many algorithms are used for this face recognition. Among them, Principal Component Analysis (PCA), Linear Discriminant Analysis (LDA), and the one we have used, EICA, and neural networks. Here, EICA is the enhanced form of Principal Component Analysis where we can add and delete the images. The tools we used are Scilab 5.1, SIVP 0.5, and NetBeans 6.8. And the platforms are Windows and Linux. What actually is enhanced independent component analysis? This is a method that derives independent components of face images by statistical algorithms, and the process involved here is about finding the basis vector for all the images. Now we'll see the architecture of EICA. Here, all the images are considered to be the training images, that is, each image is a trained image. And some pre-processing steps are applied on these training images to make them more effective. See the difference here. And now, all these images are constructed in the form of a matrix, that is, the image matrix. For this image matrix, we construct a covariance matrix, and from this covariance matrix, we find the eigenvectors. Then those are considered to be the EICA faces. And the vector size we reduced here is 50, we can make it as 25 or 70. Then we find the basis vector. Now we'll select an image for testing, that is a test image. Pre-processing steps are also applied on this test image. This test image is projected onto the EICA face space. Now the Euclidean distance is considered. For this basis vector and EICA face space, the minimum Euclidean distance is considered and an image is retrieved as recognized image. This is a sample training set of 2D images. This is the grid database and this is the ALE database. We have also used 3D images. This is a 3D database of grid and this is a 3D database of ALE. Now, we shall see the execution of our project. See, this is a Scilab console what we have used for execution, and this is the editor for writing the code. Now we'll see the execution. First we have to load all the toolboxes. Now by calling the function EICA, a dialog box will be open. From the dialog box we have to select an image for testing, that is a test image. Here, as you can see, we have given n value as 75. We can give it as 25 or 75 or 50. It's our wish. And we used two norms, that is, as I have discussed in architecture of EICA, there I discussed about Euclidean distance. Here we used L1 norm and L2 norm. See here, L1 norm and L2 norm. For this, the minimum distance is considered and the image will be displayed. Minimum of norm 1 and minimum of norm 2, as you can see here. Therefore, we'll get two output images for one input image, that is the recognized image for norm 1 and recognized image for norm 2. And we tested our project on two databases, grid database and ALE database. And we have also used 2D images, 3D images and multimodal images. As multimodal images are the one which has both 2D and 3D images. Now, here is the dialog box. We shall select an image for anything you can select. Suppose if you select this one or anything. Okay, now this is the output. Here is the input image and these two are the recognized images, recognized image by L1 norm and recognized image by L2 norm. Now, what we analyzed from our project is as I have said, we used two databases, grid database and AL database, and we have 2D, 3D and multimodal images. As you can see here, the efficiency for grid and AL, for grid is 95 and AL is 100%. The difference is because AL database is a standard database and the lightning effects are standard. That is the reason for AL the efficiency is 100%. And you can see here for 3D and multimodal the efficiency is 100%. By this we can say that for any face recognition technique, if you use 3D and multimodal, it gives better results when compared to 2D. Thank you.